This question says, boron has two isotopes, B10, which has a 20% abundance, and B11, which has an 80% abundance. And the question asks, its relative atomic mass is therefore which of the following? 100, 60, 50.5, 5.8, or 10.8. So before we do any calculations, let's review the question in more detail so we understand all of the nuance here. So first of all, we're talking about a single element, and that element is boron. And we're considering two different isotopes. So these are essentially two different versions of the same element with a different mass because of the different number of neutrons. So for example, B10, the B comes from boron, and 10 refers to the atomic mass because it's composed of 5 protons and 5 neutrons. And this isotope has a 20% abundance, so it's less common than the other isotope B11. It occurs about 20% of the time. Then we have B11, which again, similarly, has 5 protons but 6 neutrons, thus 11 instead of 10. And that extra neutron means B11 has a greater atomic mass, again being 11 instead of 10. And this isotope has 80% abundance, which means when you have a sample of boron, more of it will be composed of the isotope B11 than B10. And we're asked to determine the relative atomic mass. So think of it this way. Again, if we had some macroscopic sample, some large quantity of boron, it will be composed of both isotopes. But because it will be composed of both isotopes, it will have a mass somewhere in between B10 and B11, or in other words, 10 and 11. So with that in mind, we can actually answer this question without calculating anything at all, because we know that it will be between 10 and 11. And because B11, the heavier isotope, is 80% abundant, it's more common than B10, we should expect it to be closer to 11 than 10. So if we look at our answer options, we have 100, which is far too large. This is essentially an order of magnitude greater than what we would expect. Likewise, 60 is also too large, so is 50.5. And then we have D, which has the opposite problem. It's outside of our range just the same, but in the opposite direction. It's too small. And that leaves us with one answer option, which is E, 10.8. And again, this makes sense. It's between 10 and 11, and because we have a 80% abundance of B11, we expect it to be closer to 11 than 10, which is what we see in 10.8. But it's not always so obvious. You can't always do such a process of elimination, so it's important to understand how to calculate this. And to do so, you can do the following. You can take the mass of one isotope, so for example, in this case, we have 10, and multiply it by its abundance. So the abundance of the first isotope is 20%, so we have 10 times 20. And we can do the same thing for each isotope. So we sum that with the mass of the second isotope, which is 11, times its abundance, which is 80. And because we're concerned with the relative atomic mass, this is all divided by 100. Now, if we perform this calculation and simplify, we get 200 plus 880, and again, still divided by 100. So the result is 1080 divided by 100. So the final answer we're going to get is equal to 10.8. So this again confirms our previous answer that we determined through process of elimination and heuristics. So once again, the correct answer is E, 10.8.